This video is for Advanced Algebra 1. This will be Chapter 1 review video. And I'll have to go back and forth between the worksheet this is on and regular paper because there's not enough room on here for me to show all of my work. So anyway, we'll be going back and forth with that. Question 1 says, which of the sets shown includes the elements of set Z that are both negative numbers and multiples of 4? So here's a negative number, negative 34, but it is not a multiple of 4. Negative 28 obviously is negative, and it is a multiple of 4. Negative 16 is obviously negative. 2 is a multiple of 4. Negative 2, not a multiple of 4. And then 4, 8, 12, 26, not negative. So the answer is just these two, and that is set A. So set A is our answer to that one. Order the numbers from least to greatest, and I just go right to my calculator for that and find the decimal equivalent. 45 over 11 is 4.09. Repeat, by the way. And obviously this one is 4.5. They have that one figured out for you. The square root of 20, 4.47, and square root of 45 over 4, 3.35. So from least to greatest, the smallest of those then would be the 4.09, so 45 over 11. And then, I'm sorry, I just messed that up totally. I forgot about that 3.35 at the end there. So that is the smallest, square root of 45 over 4. Then would be 45 over 11. Then we would have 4.5, and then the square root of 20. So smallest to largest. Which of the following will result in a rational number? Select all that apply. Remember, a rational number is the number that can be written as the ratio of two integers. It's a number that can be written as a fraction. And so when I look at this, the square root of 12 is not a perfect square, so that's going to be irrational. Even if I add a rational number to it, so it cannot be that one. And then same thing, square root of 12 is irrational. So, there's no way this is going to turn out to change that. And then the square root of 36 is 6. So this is the same as 5 over 6 minus 6 over 3. That's going to be a rational number. It's a fraction. A number that we can write as a fraction. Then same thing here, the square root of 36 is 6. So this is 5 over 6 divided by 6 over 3, and that's going to also be a fraction. So those are my two answers. Okay. Next problem, we're supposed to solve this equation. Go to another sheet of paper here. We have 3 times the quantity 2x minus 5 minus 4x plus 8 equals 1. So distributive property first, 6x minus 15 minus 4x plus 8 equals 1. Then I would combine like terms. 6x minus 4x is 2x, and negative 15 plus 8 minus 7. Then I would add 7 to both sides. I get 2x equals 8. Then I would divide both sides by 2. X is 4. And There's my answer. Number 5, the sum of 3 consecutive even integers is 72. What are the 3 numbers? So remember, consecutive even integers, if you think of them on a number line, they're 2 units apart. So we can represent the numbers as x, x plus 2, and x plus 4. And then it says their sum of those 3 integers, so x plus 2 plus x plus 4 is 72. And so I add like terms over here, I get 3x plus 6. I subtract 6 from both sides, and I get 3x is 6. And divide by 3, x is 22. And then that's not the answer. The answer is 22, 24, and 26. Okay, because it wants to know the 3 integers. The next problem we have here, number 6, is a what I call a number value total problem. And so that she has, she's buying blue fabric and she's buying green fabric, right? Across the top, amount, value, in. She buys 5 yards of blue fabric. It's going to go here. And the blue fabric costs, oh, I'm sorry, and 8 yards of green fabric. That's going to go there. And the blue fabric costs $2 more per yard than the green fabric. So the green would be X, the blue would be X plus 2. And then we multiply across. Here we get 5X plus 10. You're already doing that distributive property. And here we get 8X. And then she spent a total of $62. So that's where my equation comes from. 5X plus 8X plus 10. I'm sorry, 5X plus 10 plus 8X. It doesn't really matter, but 5X plus 10 plus 8X equals 62. So adding those together, subtracting 10 from both sides, I get 13X equals 52. And divide both sides by 13. Divide this by 13, divide this by 13, and I get X is 4. And so now we go back to the question, what would be the combined cost of 1 yard of blue fabric and 1 yard of green fabric? So the green fabric is $4 per yard, right? We discovered that. And the blue fabric is $6 per yard. So if I bought a yard of each, that would be $10. That is okay. Okay. Next problem. We have 5X plus 2 minus 2 times the quantity X minus 1 equals 3X plus 4. So looking at the choices we have for an answer, this is one of those problems where they're trying to suck us in and think we're doing it wrong because we're going to get something that doesn't make sense probably. So first of all, I need to distribute this -2, okay, which is going to leave me with 5X plus 2 minus 2X plus 2, because I'm distributing the -2, okay, equals 3X plus 4. Notice that when I combine like terms over here, I get 3x, and then 2 plus 2 is 4. And when does 3x plus 4 equals 3x plus 4? That's one of those cases where we get a true statement, and therefore our solution is all real numbers. Okay. Had we gotten our false statement, our solution would be no solution. And another way of saying all real numbers is that there's infinitely many solutions. There's so many solutions we can't even begin to count. Infinitely many. So that's our answer to that one. Next problem, we have fractions to deal with here, which is fine. We can do fractions. Darn good at them. 3/4 times the quantity 6x plus 1 minus 3x equals 1/4 times the quantity 2x minus 1. And so we distribute the 3/4. I'm going to choose to do, and I get 9 over 2x, okay, plus 3/4 minus 3x. I'm going to distribute the 1/4 over here, equals 1/2 x minus 1/4. I could go through and multiply everything by 4, get rid of the fraction. I'm not going to. I am going to subtract 1/2 x from both sides, because that gives me 9 halves minus 1/2 is 8 halves, and 8 halves is 4. Plus 3/4, that 3x is still there, equals 1/4. Now what I'm going to do is I'm going to combine like terms here and here. I get x, and I'm also going to subtract 3/4 from both sides. 1/4 minus 3/4 is negative 2 over 4. Negative 2 over 4 is negative 1/2. And that's my solution to that problem. That's what they're asking us to find. Okay? We dealt with those fractions. So there. So we have S equals A plus L times W. And we want to solve for W. So the first thing we need to get rid of is the A. So I need to subtract A from both sides. S minus A equals L times W. And then I need to divide both sides by L. So I get S minus A all over L equals W. Let's see. S minus A, that's that one, all over L. Okay. For 11 here, says to write the formula for the volume of a square prism and the volume of a square prism is V equals 1/3 S squared H. I don't like S as the variable. It's okay, we'll deal with it. In terms of H, so in other words, solve this thing for H. The first thing I would do is I would multiply both sides by 3. And that would give me 3V equals S squared H. And as it said, we're solving for H. So now I would divide both sides by S squared. And so H is 3V over S squared. And they're asking for the formula here. That's the formula. That's our answer for the formula. 3V over S squared. Now, if we have a volume of 60, in other words, substitute in 60 for the volume, and the side length is 6, solve that for H. Simplify that. I get 180 divided by 36, and I get that H is 5. And the units on that would be centimeters. So the answer here is 5 centimeters. Okay. Number 12 here, we have negative 2 times the quantity x minus 3 minus 4 is greater than or equal to 3x minus 5 times the quantity x minus 1. So lots of distributive property and lots of distributing the negative. Two things that we've been working on this whole unit. So let's see, let's figure this out. So I'm going to distribute the negative 2 first, and I'm going to get negative 2x plus 6. I distributed negative 2 minus 4 is greater than or equal to 3x, and now I'm going to distribute this negative 5. Okay, so that's going to be minus 5x plus 5. Okay, I'm going to add like terms. Over here I get negative 2x plus 2. Over here I get negative 2x plus 5. And we go to get our x's together, and they drop out. I get 2 is greater than or equal to 5. Two is greater than or equal to 5, and that is a false statement, correct? It's a false statement, so therefore there's no solution. And that is choice C on there. Okay. Had we gotten a true statement, the answer would have been all real numbers. Okay, but we get a false statement, therefore there's no solution. And number 13, we have negative 2x plus 5 times the quantity x minus 2 is greater than 7x minus 6. So the distributive property again, just can't get away from that. 2x, distribute the 5, I get plus 5x minus 10 is greater than 7x minus 6. Add like terms, negative 2x plus 5x is 3x. Okay, and then I like my variable to be on the left, so I'm going to subtract 7x from both sides. I get negative 4x minus 10 is greater than negative 6. I would add 10 to both sides, and negative 4x is greater than 4. Okay, now the quiz we just took, there was some errors there that were consistent with several people. And I'm going to finish this problem and then I'll tell you what those were. I'm going to divide here by negative 4. Okay, and when we divide by a negative, we flip that inequality. So this becomes x is less than negative 1. Okay. Only when we divide by a negative or multiply by a negative do we flip that inequality. And then to graph that, we would put an open circle on negative 1. And because I have my variable on the left, my graph is going to go the same way as x is less than negative 1. Okay. Here's what I saw on the quiz that we just took Friday. We had like 4x is greater than negative 8. And so people divided both sides by 4, which is the right move, and then they flipped the inequality. That is incorrect. The only time we flip that inequality is if we divide by a negative, not if we take a negative divided by a number. okay? It's when we divide by this number in the bottom has to be negative, okay? Or when we multiply by a negative, which is rare that we do that anyway. So anyway, I just wanted to make sure we got that understood and so that we know, because this will probably show up on the test as well, we know that when do we flip that inequality and when do we not flip that inequality. Okay. And then number 14 here, we have the compound inequality. So we solve each one of these separately. It's an and problem, but they still did not write it as one sentence, so we got to solve it separately. We have 2 times the quantity x minus 2 plus 7 is greater than negative 1. So we distribute the 2. 2x minus 4 plus 7 is greater than negative 1. We combine like terms over there. 2x plus 3 is greater than negative 1. We subtract 3 from both sides. 2x is greater than negative 4. And then we divide both sides by 2. And we get x is greater than negative 2. And then we write down this other one. 5 minus 4x is greater than 9. So subtract 5 from both sides. And I get negative 4x is greater than 4. Divide by negative 4. And I get x is less than negative 1. Okay. And you could write this a number of ways. We could actually write this as a one compound inequality, but the easiest way to probably write this would be x is greater than negative 2 and x is less than negative 1, because it's a matching problem, and so we want to find x that's greater than negative 2 and x is less than negative 1, which looks like the answer is D. Okay. So what we do here, first of all, I'm going to write the absolute value of 6 minus x equals 3. I'm going to write it this way. And if you recall, what we do at this point is we apply the definition of absolute value. You could totally work this problem backwards and plug in these numbers and see which ones work and find your answer that way. I'm not going to go with that strategy. I know how to solve this, so I apply the definition of absolute value, which means 6 minus x equals 3, or 6 minus x equals negative 3. And I solve each one of those separately. So here I subtract 6 from both sides. I get minus x equals negative 3. And then I divide everything by negative 1. I get x equals 3. Here I subtract 6 from both sides. I get minus x equals negative 9. Divide by negative, x equals 9. So that's my answer. And we have an inequality with absolute value. And so we cannot apply the definition of absolute value until the absolute value is maxed out. So before I can go into applying that definition, I have to subtract 1 from both sides. I get 2 times the absolute value of x plus 3 is greater than 2. Remember, you cannot distribute into absolute value either. They're not parentheses. These are absolute value bars. I cannot apply the distributive property here. I have to divide both sides by 2. So I get x plus 3. The absolute value of x plus 3 is greater than 1. And now I can apply the definition of absolute value. We have a greater than problem. So this is an or problem. We say that x plus 3 is less than negative 1, or x plus 3 is greater than 1. And I solve both of those. Here I subtract 3, x is less than negative 4. Here I subtract 3, x is greater than negative 2. And then to graph that, greater than -2 would be an open circle here, that way, and less than -4 would be an open circle here, going that way. And that's all there is. Our answer would be, this graph, and then on the test, if it's not a multiple choice, I would also ask you to put x is less than -4 or x is greater than -2. The statement down here. Okay, so that is it. This will be exactly like the test. Like I said, just names the numbers will be changed to protect the innocent. And so if you have questions or there's something you don't know how to do on that review worksheet, that's something you have to get rectified. Okay?